Okay, this review is on system of inequalities. So before we go to any examples, I want to remind you that if you have a less than or equal to, you want to shade below the line. Greater than or equal to, you shade above it. If you have just a greater than or less than with no line, you have a dashed line. But if you have a line under the inequality, you should have a solid line. Alright, so let's look at the first example. I have y is less than negative 3x minus 2. So I'm going to go ahead and graph that like I would a line. My y-intercept is negative 2. My slope is negative 3, so I'm going to go up 3, 1, 2, 3 over 1. Up 2, 1, 2, 3 over 1. Okay. I have a dashed line, so I'm just going to draw dashes through this line all the way through. Put arrows on the end. And it says I'm less than, so I'm going to shade below this line. So this is where I would be shading below that line. Alright, my other line is x plus 2, so my is here, and my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, same way this way. I have a solid line, so I'm going to draw a solid line through this point. And my inequality here says I'm greater than, so if I'm greater than, I'm going to shade above, so I'm going to be shading here. So my intersection is where the two areas overlap. So this would be my shaded area. Okay, so that's how you do those. Alright, the second problem we're going to look at is I have a solution of the graph is shown below. So we want to know which solution, one of these points would be a solution. So let's plot these. So 0, 3, I have a plot negative 3, 1, 2, 3, positive 4, 1, 2, 3, 4, negative 2, 1, and negative 2, negative 2. Okay, so there are my four plots. Now, right off I can see that B, this is B here, B is a solution because it's in the shaded region. This one is not, okay, so this would not be one, but this would. But now I'm looking at A and C, and they are on the dashed line, okay. A definitely would not be because it's only in one region, but it's on this dashed line. So remember, the dashed line just means like less than or greater than. It does not mean equal to, so this would not be. And the same thing goes for my point here, point C, because it's on the line, while it's in the shaded region of both, it's on this line, and that means less than, not or equal to, so this would not be. So the only solution here is B. Okay. Alright, so let's look at the next example. Alright, so our next example is not written in slope-intercept form, so we have to rewrite it. So here you would subtract 5x from both sides. I have 3y is greater than negative 5x minus 9. Divide by 3 each term, and I wind up with y is greater than negative 5 thirds x minus 3. So let's go ahead and graph that one. So my y-intercept is negative 3. My slope is negative 5 over 3, so I'm going to go up 5, 1, 2, 3, 4, 5, and over 3. I can't do anything else, so this one is a no line, so I'm going to draw a dashed line through here. Putting arrows on the end. Alright, it says I'm greater, so that means I'm going to be shading in this area here above that line. Okay, so let's solve our next one. Got to rewrite it to y equals mx plus b, so I'm going to subtract x. I have 3y is less than or equal to negative x plus 3. Divide by 3, divide by 3, divide by 3, I get y is less than or equal to negative 1/3 x plus 1. So my y-intercept here is 1. I'm going to go up 1 over 3, down 1 over 3. To get, this is going to be a solid line through this point. And it says y is less than or equal to, so I'm going to shade below the line there. So my intersection is right here in this little shape here. So that would be my intersection. So that would be the solution to that system. Alright. keep in mind that whenever we're rearranging our equations, that if you have to divide by a negative, you must switch the inequality. Okay, so that's only if you have a negative with the variable and you have to divide that negative out. I hope this helped with your review of inequalities. If you have any questions, ask me in class. Good luck on your review.